Hello friends, very good afternoon. Hope my voice is audible to you all. Is it clear? Hello?
Yes,
Yes,
sir.
sir.
Okay. So today we'll start with distributed databases and the topic that we already started, that is concurrency control mechanism. In concurrency control mechanism, there are various protocols that we are actually studying. And in this particular protocols, we have already gone through the first two protocols, and now we have to go with the next other protocols. So let's have a initiation that I'll go with review of last session. Then I'll cover bias protocol. Then I'll cover the last protocol, that is Quorum Consensus protocol. So let's start with distributed lock manager, and we have already taken this types of what the approaches or the protocols. Okay, so there are basically primary copy, majority protocol, bias protocol, quorum consensus protocol. So there are basically four types of protocol, and one more type that I have already told you, that the timestamping protocol. So here, in case of primary copy protocol, we need to choose. I have already explained this particular part. There will be a multiple copies because we are talking about replication. In case of replication, there will be duplicate copies or replicated copies of that particular part. Okay, and we have to choose any one replica of, and we have to announce that particular data. We have to choose any replica of data item, and we have to announce that it is a primary copy. So once primary copy is decided, and whenever this particular data item will reside, wherever we are saying that it will be a primary copy, in that case, that particular site will also be known as primary site. So this is what an idea that we need to take from this, that site containing the replica is called as primary site of that particular data item. And rest all other data items will be having what? Its replica. So different data items can have different primary sites. So this is what the beauty of distributed lock manager that we have seen. In case of the single lock manager, we have seen the problem of bottleneck. Okay, where everyone is requesting, because the lock manager is available at only one site. So every data item, okay, and that particular lock manager, every transactions are what sending request to that particular lock manager, and that may become bottleneck. One more issue with the site, one more issue with your one more issue with your single lock manager is that, just wait please. Yeah, very sorry friends. Yeah, so I'm talking about in case of primary copy, items can have different primary sites. So in case of single lock manager, what were happening, in case of single lock manager, everything was based on that single lock manager. So everyone was demanding the data item lock request to the single site, and if that site gets what, if that site gets down, then there will be a biggest problem. Okay, to solve that issue, we are actually talking about distributed lock manager, and in that there are various approaches, and from that today we are learning with what the primary copy approach. So with this primary copy approach, when a transaction needs a lock to any of the data item, in that case we need to send the request to that particular lock for the primary site. And based on that, based on that, that manager will observe if the data item, if the things can be given, then it will lock that particular data item, as well as it will lock all the replicas of that particular data item. That's the beauty of primary copy uh, approach. We have seen the benefits of primary copy approach. Concurrency control for replicas, for replicated data handled similarly to unreplicated data, and this kind of implementation becomes what, very simple implementation. So the best benefit of primary copy is what, it is easy for implementation. But the severe drawback of this primary copy is that if the primary site gets failed, in that case, that data item, though its replicas are available, but we cannot able to use that because it will be locked by that particular primary site, and that will be the problem with primary copy. After that, we have seen majority protocol. I have already told you that in majority is actually playing great role. So majority will definitely work out here, where the majority protocol is telling you that here there are certain assumptions that local lock manager at each site administer lock and unlock request for data items stored at that particular site. Then there will be, when transaction wishes to lock an unreplicated data item at a site, a message is sent to SI lock manager. SIS lock manager. When the data item, any data item, we need to check whether its copy is available at which particular site, and then the request is sent to that particular lock manager. Based on that request, the lock manager will take care that queue is locked in incompatible mode if and only if, okay, sorry, if queue is locked in incompatible mode, then the request is delayed until it can be granted. Okay, and when request is granted, then naturally the message will be sent to that particular site, that transaction, that the request is granted. But how we can able to take the decision in this was very simple when there is no replicated copy. But when we have replicated data item, means a having multiple copies cache available at different sites, in that case what we need to do, we need to think about this particular model. If queue is replicated at n sites, then lock request message should be sent to n by 2 sites, okay, where the queue is stored. So I have already told you about this particular part yesterday, where the data item, okay, means n by 2 request will be sent. Now what is this n? N will be what? The replica ratio. Means if n is 10, it means that q data item is replicated 10 times at different sites. So this is what an idea. In that case, we need to send the request to at least 5 sites. And whenever we are getting what, whenever we are getting the messages that yes, we can able to give the access, and when majority will come, then the access to that particular data item will be given. So this is what the beauty of this this is what the beauty of this particular scheme. So this I have already explained, but this is what the part where the benefits and drawbacks of majority protocol is that benefit, it can be used even when some sites are unavailable. So this is what the beauty, because availability is higher here. Okay, so this can be used, though there are certain sites which are not available, because n by 2 we are talking about. So half site भी आपके बंद हो गए, 50% sites भी आपके नहीं चल रहे हैं या failure आया है, उसके बावजूद भी ये काम करेगा. So that is the beauty. Second, details on how handle rights in the presence of site failure later, that can again will be very easy. यानी मेजर जो अपना साइट है वही यदि फेल हो गया, उसके बावजूद भी उसको लॉग रिकॉर्ड का यूज करके हम लोग क्या कर सकते हैं, राइट कर सकते हैं. दैट्स द बेनिफिट ऑफ दिस पर्टिकुलर स्कीम. Now the drawback of this particular scheme is that it requires 2 by n by 2 plus 1 messages for handling lock request and n by 2 plus 1 messages for हैंडलिंग अनलॉक रिक्वेस्ट. ये इतने मैसेजेस हम लोगों को क्या करने पड़ेंगे, भेजने पड़ेंगे. उसके लिए रिप्लाई जो भी है वो रुकना पड़ेगा. पोटेंशियल फॉर डेडलॉक इवन विथ अ single item, single data item. An example here is given. Each of 3 transactions may have lock on 1/3 of replica of that particular data item, and this particular issue will lead to deadlock. So deadlock क्यों आएगा दोस्तों, क्योंकि there may be possibility that कि आधे साइट ने बोल दिया है कि ये लॉक मैनेजर जो भी है इसको रिक्वेस्ट ग्रांट करना है, आधे साइट ने ये बोला है ना 50-50% रेशियो वहां पर आ सकता है. उस पर्टिकुलर केस में डेडलॉक जो भी है वो आने के चांसेस हाइयर है. Now the next protocol that we have to focus today, that is biased protocol. अब आपको biasing का meaning काफी अच्छी तरीके से पता है. आप हमेशा बोलते कि partiality होते रहती है. Okay, so biasing and unbiasing, this is what the important part here. Okay, so what is this bias protocol? So let's focus on this part. Local lock manager at each site, as in majority protocol. However, request for shared locks are handled differently than what the request of exclusive lock. तो यहाँ पर क्या होता है, जैसे मेजॉरिटी प्रोटोकॉल में होता था कि रिक्वेस्ट शेयर्ड लॉक का जो भी रिक्वेस्ट होता है, ओके, और एक्सक्लूसिव लॉक का जो भी रिक्वेस्ट होता है, दैट इज हैंडल्ड डिफरेंटली. सो दैट वी नीड टू फोकस. दिस इज व्हाट द इंपॉर्टेंट पॉइंट. Now what is happening with shared lock and what is happening with exclusive lock? So let's focus on shared lock. When a transaction needs to lock data item q by using this shared lock, it simply requests a lock on q, and lock manager at one side containing its replica will be what? Locked. Any site, the moment we are getting that particular replica, though it may be primary copy, it may be replica copy, once we got it, that lock manager may grant that particular request, because we are talking about shared यानी क्या करना है, सिर्फ read mode के लिए इसको क्या किया जाएगा, read only mode will be used in case of your shared lock. Now, next part is exclusive locks. In case of exclusive lock, you all are aware that in case of exclusive lock, we need to perform read as well as write operation. So updations can be possible, and that is the reason when transactions need to lock data item Q, it requests at all sites containing the replica of Q. यानी क्या उनको क्या किया जाएगा, लॉक किया जाएगा, because we are talking about updations. Example, let's take an example of data item A. I'm updating the value of A from 50 to 100. Okay, the moment I'm doing this particular part, it may take some time. Okay, and in between, if somebody is reading that particular value, it may read the old value like 50, but it was expected that the value should be read, that is what is the updated value which is there, that should be read. So in case of exclusive lock mode, we need to data items available on each and every site. I'm talking about replicas of all the data items that we need to lock in case of your exclusive lock mode. Now, the benefit of this particular scheme is that it imposes less overhead on your data item. Okay, and the severe drawback of this particular scheme is that we need additional overhead on what? Write operation. Okay, very simple. As far as to manage shared lock is very simple, but to manage exclusive lock is what somewhat overheads will be there. Why there will be overheads? Because we need to lock each and every copy which is available, means each and every replica of that particular data item may be available at different sites. So that particular headache will be there in case of this scheme. Now the last protocol and the last topic of this particular unit is Quorum Consensus protocol. Now here we need to understand a generalization of both majority and S will be what? It is total of all the sites. Okay, total all the sites. Okay, means every site will be having its own associated weight. Okay, and the total of entire weight will be S here. Now the next part, we have to choose two values. One is read quorum, that is QR, and write quorum, that is QW. So we need to choose two values. So here it is quorum consensus. So we have to choose two values, that is one value for read quorum and another value for write quorum, that is QR and QW. I'll again repeat for you all that S will be the total weight of all the sites, QR will be the read quorum, and QW will be the write quorum. So these are three total values that we need to understand. And based on it, we need to focus on this particular formula. Okay, each site assign this particular weight such that QR plus QW should be greater than S. Means the value of read quorum plus the value of write quorum should be greater than, its addition should be greater than the total weight of all the sites, that is S. And in case of your write, 2 into QW should be greater than what? S. So write quorum, okay, we need to double it by multiplying it by 2, and it should be greater than what? S. So this is what the condition. Okay, and if this particular condition is getting satisfied, quorum can be chosen and S will be computed separately for each and every site. So every time we need to do this particular part. Now, each read must lock enough replicas that the sum of the site weight is greater than or equal to QR. यानी आपको वो जो भी टोटल रहेगा S का, वो कैसे करना पड़ेगा? आपको इतने साइट्स को क्या करना पड़ेगा? इतने साइट को कंसीडर करना पड़ेगा जिसका टोटल जो भी रहेगा दैट शुड बी ग्रेटर रीड से उसका जो भी पर्टिकुलर है, कितने साइट्स को लॉक करना है यहाँ पर आएगा. इन केस ऑफ मेजॉरिटी n/2 ये फिक्स था. ओके, इन केस ऑफ बायस्ड हम लोगों ने ये देखा कि रीड के लिए और राइट के लिए सेपरेट था. तो यहाँ पर क्या है, दोनों का कॉम्बिनेशन यूज किया जा रहा है. सो दैट नंबर इज नॉट फिक्स्ड. वो कहा कब तक उसको एडाप्टिव किया गया है? इट्स वेट शुड बी व्हाट? ग्रेटर देन QR. Okay, and QR is what? Read quorum here. In case of write, Okay, each write must lock enough replicas that the sum of site weight is greater than or equal to QW. तो यहाँ पर सिंपल है, रीड के लिए आपको जो भी वैल्यू, जितने साइट्स को आपको कंसीडर करना पड़ेगा जिसका समेशन क्या रहेगा, ग्रेटर देन और इक्वल टू QR, और यहाँ पर जो भी समेशन रहेगा दैट शुड बी ग्रेटर देन और इक्वल टू QW. Here QW. Finally, for now we need to assume all replicas are written. Extensions to allow some sites to be unavailable, that will be what described later. So here we need to think on what these two particular values, and once we understood this, then the problem will be what solved. Now the last, sorry, I actually forgot to tell you that this is what the last protocol, that is timestamping. Okay, so we have seen the timestamping. In case of single site, it is very simple. You can either use that particular date and time, which is enough. But in case of multiple site, we need to use that IP address also. Means we need to use the site number plus that date and time. So S1 date and time will be different than S2 date and time. So at a time, if I read two values of timestamp of different sites, that may be same. In case of date and time, it will be same. But when I'm adding one more parameter, that is site number, it becomes what? It becomes unique. And that is the logic. It is actually type of concurrency control protocol. It is mainly used into your distributed system, where we need to think about multiple sites, because here we are talking about distributed system. Each transaction will, it must be unique timestamp. And how that unique timestamp will come up, when we are talking, we are including what timestamp, along with timestamp, we are including the site number. So what will happen, if you observe this particular diagram, you can understand how to generate timestamp is the big challenge in case of distributed fashion. Okay, so it is clearly indicated in this particular example, where I am talking about what, this local timestamp. Okay, this is the local timestamp. Okay, so local timestamp can be your date and time, or it can be counter. I have already given you sufficient explanation in case of transaction processing. How timestamp can be generated, it will be based on clock or it will be based on counter. So that will be this. And apart from that, I have already told you about this, that site identifier, that is site number S1, S2 will be added. And combination of both of this will become your global unique identifier. So what will happen, date and time plus site number will be added. So that's the beauty of this. So each site generates a unique local timestamp. Okay, that may be counter or it may be based on what, clock. Okay, another part using either logical counter or logical clock. This I have already told you. So clock is also shown and counter is also shown to you. So how global unique timestamp will be computed? It will be obtained by concatenating unique local timestamp along with the unique identifier number. This unique identifier number is ultimately site identifier number, that is site number. For example, in case of, let's say, site S1, if I take S1, okay, so S1, okay, it will be along with this S1, what we need to do, we need to take, let's say, counter. Suppose counter is 10. So 10, this particular value may come from 10 different sites, but this will be what for site 1, this will be for site 2, this will be for site 3. So likewise, we can go with what? We can go with 10 sites. So like S10. So 10 will be same, but it will be differentiated by this unique site number, that is S1, S2, S3 and S4. And you can observe all these numbers will become what? The unique number. So this we need to understand, and it is very, very simple to identify. Okay, so this way you can able to, uh, create this many numbers. Now, in case of site, a site with slow clock will assign smaller timestamp. Still logically correct, serializability will not be affected. For example, यहाँ पर smaller timestamp यानी क्या, आप फिलहाल ऐसा समझ लीजिए कि डेट और टाइम जो भी है, ओके, वो पूरा ये ना करते हुए सिंपली हम लोग को क्या करना रहेगा, यहाँ पे उसका शॉर्ट डेट लेना पड़ेगा, शॉर्ट टाइम लेना पड़ेगा. दैट इज ऑल्सो इनफ बिकॉज इट विल नॉट डिस्टर्ब योर serializability. But the disadvantage of stage of this particular will be what, there may be possibility of what, certain transactions may get disturbed, because when there is matter of fractions of second, then definitely we need what, the bigger timestamp having entire details of date as well as what time with millisecond. So that is the beauty. To fix this problem, define within each site Si a logical clock, that is LCI, which generates the unique local timestamp. And then Si advance its logical clock whenever request will be what received. So ultimately it will become what, it will become the counter. यानी 1 हम लोगों ने इनिशियली उसको किया रहेगा, जब भी रिक्वेस्ट आएगा उसको 2 करो, और कोई रिक्वेस्ट आया 3 करो. So likewise upon receiving of each and every request we can increment the value of that timestamp. So it will become what, your unique timestamp. So instead of date and time, what we will use, we will instead of clock, we will use what, counter here. So we can able to fix up that particular problem. Okay, now here there may be possibility of what, deadlock. So if deadlock will come, we have to always take care, and I hope we have taken sufficient discussion on what deadlock handling. So I'll simply show you this particular part how we can able to handle the deadlock. So I hope you remember the wait for graph. Okay, showing you here. You need to understand, suppose this is wait for graph. आपको याद होगा wait for graph हम लोगों ने निकाला हुआ था. What is it? Here it indicates that T1 has locked some data items. Okay, T1 has locked some data items. T2 also locked some data items, but it is dependent on T1 because T1 has locked a data item which is actually needed to T2. Same T2 is also dependent on what, T3. T5 is also dependent on what, T1. So ये एक side का हो गया. This is side 1. Same here, this is what the local wait for graph that is for site number 2, where it is indicating that T2 has locked some data item, T4 also locked some data item, and it is dependent on what, T2. Again here T3 has locked some data item, but it is dependent on T4. यानी जब तक T4 कोई डेटा आइटम को रिलीज नहीं करेगा तब तक T3 एग्जीक्यूट नहीं होगा. तो ऐसा यहाँ पर हम लोग को दिख रहा है. तो यहाँ पर भी साइकिल नहीं है और यहाँ पर भी साइकिल नहीं है. तो ये लोकल साइड के लिए ओके है, बट वी नीड टू कंबाइन दिस ग्राफ. इस ग्राफ को कैसे कंबाइन किया जाएगा? सो फोकस हियर वेरी केयरफुली. सी दैट हियर इट इज कॉमन. T2 and T3 is common here, and here also it is common. तो ये ग्राफ को सिंपली क्या करना है, आपको यहाँ पर कंबाइन करना है. How it will be combined? So see this particular part, you can easily focus on this. That यहाँ पर आप देखिए, ये वाला जो भी पार्ट यहाँ पर लिया है ना, ओके, ये एज इट इज यहाँ पर आ गया. दिस इज एज इट इज हियर, अवेलेबल हियर. ओके, ये वाला जो भी पार्ट है, ओके, ये भी एज इट इज यहाँ पर आ गया. ओके, ये लोकल वाला पार्ट जो भी है वो एज इट इज यहाँ पर आ गया. ओके, इसके ऊपर आगे T2 और T3 इसको भी एज इट इज हम लोगों ने लिया, लेकिन देखिए इसमें चेंजेस क्या है. T2 से कहां पर आर्क जा रही थी, T1 के ऊपर. सो दैट इज अवेलेबल हियर, तो ये यहां पर आ गया. देन T2 वर डिपेंडेंट ऑन व्हाट, T3 यहां पर नहीं है. ओके, लेकिन साइट 1 पर था, इसलिए यहां पे आर्क आ गया. सो दिस इज वन थिंग. यहां पर T3, यहाँ पे T4 है ही नहीं. ओके, तो यहाँ पर आप लोगों को दिखाई देगा कि यहाँ पर T4 था, T3 T4 के ऊपर डिपेंडेंट था. तो ये वाला आर्क जो भी है वो उस पर्टिकुलर केस में आ गया. सो दैट वी नीड टू अंडरस्टैंड. सो लाइकवाइज ये वाला भी यहाँ पर आ गया. तो इस पर्टिकुलर ग्राफ को क्या किया गया, सिंपली कंबाइन किया गया. सो व्हाट वी डिड, वी हैव कंबाइंड दिस बोथ द ग्राफ्स. ओके, दैट इज graph of site 1 and site 2 is here combined, and this when we are combining more than one local graph, that graph becomes global graph. अब इस global graph में आपको चेक करना है कि साइकिल है या नहीं है. तो आप यहाँ पर देखोगे T2 is dependent on this T3, T3 is dependent on T4, and again it is dependent on what, T2. So here it is what, cycle. And due to this cycle, you can understand very well, understand due to this particular cycle, we can say that it is known as डेडलॉक. यहाँ पर डेडलॉक जो भी है वो क्या हो चुका है, डिटेक्ट हो चुका है. सो दोस्तों, इट इज वेरी वेरी सिंपल टू अंडरस्टैंड. ये यहाँ पर ये डायग्राम भी आप लोगों को ये दिखाई देगा कि एंड ऑफ द डे जब दोनों डिफरेंट साइड्स के ग्राफ आप क्या करोगे, कंबाइन करोगे, तो आप लोगों को यहाँ पर क्या मिल रही है, साइकिल मिल रही है. यहाँ पर साइकिल थी क्या, नहीं थी. ओके, सो नो डेडलॉक. यहाँ पर साइकिल थी क्या, नो डेडलॉक. सो एट साइट 1 देयर इज नो डेडलॉक. At site 2, there is no deadlock. But when you combine these two graphs into one, that is in case of global graph, you will find this particular cycle. And when there is cycle, we all are aware that there is surety of what, deadlock. So deadlock will be detected by using this global wait for all. If you have any doubt, you can please let me know about this. Okay, now simple wait for graph, okay, giving you false cycle. Okay, now see that site 1 has this particular graph, site 2 has this particular graph, and now what will happen, you know, यहाँ पर T1 T2 के ऊपर डिपेंडेंट है और T3 T1 के ऊपर डिपेंडेंट है. तो आपके पास ये वाला जो भी है ये ग्राफ आएगा. सो T1 इज डिपेंडेंट ऑन T2 एंड T3 इज डिपेंडेंट ऑन T2. तो सबसे पहले किसको अपना एग्जीक्यूशन करना पड़ेगा, T2 को अपना एग्जीक्यूशन करना पड़ेगा. फिर T1 को, और तब जाके क्या होगा T3 को। तो यहाँ पे सीरियलाइजेबिलिटी आ जाएगा। सो T2 विल बी एग्जीक्यूटेड फर्स्ट, then T1 will be executed, and then T3, because this dependency shows that particular part to us. Okay, so now how false cycle will be there, because here we will understand that T1 is dependent on T2 and T2 is dependent on what, T3. But here you can see that T1 is dependent on T2, T2 is dependent on T3, and T3 is again dependent on T1. तो हमें क्या लगता है, एक्चुअली यहाँ पर क्या आ चुका है, साइकिल आ चुका है। आप लोगों को इसके लिए ग्राफ थियरी का नॉलेज लगेगा, डेटा स्ट्रक्चर का, ओके, वेयर यू विल अंडरस्टैंड कमिंग वंस अगेन इन द पाथ, वी कैन से देयर इज व्हाट, देयर इज, ओके। लेकिन लॉजिकली यहाँ पर साइकिल नहीं है। आप देखिए यहाँ पर साइकिल है क्या, नहीं है, देयर इज नो साइकिल। Okay, so this type of graph may generate sometimes false cycle. So programming knowledge will not be enough here, where though T1 may come here but it is not a cycle. So यहाँ पर आपको ये गलत तरीके से बता देगा कि आपको क्या मिल चुका है, डेडलॉक जो भी है वो मिल चुका है। But for this what we need to do, we need to remove something from this. So क्या आप लोगों को यहाँ पर करना पड़ेगा, तो यहाँ पे हम लोग सिंपली इसको इस तरीके से लिख सकते हैं। ये वाला ग्राफ, इन दोनों को कंबाइन नहीं करना है, आप डायरेक्टली इसके थ्रू लिखिए। अब देखिए प्रॉब्लम क्या था, यदि मैं इसको कंबाइन करता हूं तो ये क्या था, ये आपको ये देगा कि T1, ओके, T2 विल बी एग्जीक्यूटेड फर्स्ट एंड देन व्हाट, T1, ये आपको ऐसा दे रहा है, ओके। या फिर हम लोग यहां पर इस तरीके से लिख रहे हैं कि पहले T2 क्या होगा, एग्जीक्यूट होगा, ओके। दिस इज फॉर साइट 1, दिस इज फॉर साइट 1, ओके, दिस इज फॉर साइट 1। नाउ फॉर साइट 2, again we can write down like this, T3 and T1 likewise. So this is for site 2. And what will happen when we combine? So I'm talking about when we have to combine, we need to combine this also. When I combine this, what will happen? What will be the resultant sequence? The resultant sequence will be like this. T1 gives us T2. ये फर्स्ट वाला पार्ट हम लोगों ने उठाया, ओके। then it is combined with T3, then it is combined with what, T1, okay। इस तरीके से इसको हम लोगों ने क्या कर दिया, ग्लोबल के लिए इसको लिख दिया। So this will become what, global, okay, and that shows false cycle because T1 is available and again T1 is coming. So T1 से स्टार्ट होके फिर से T1 के ऊपर आते हैं तो उसको हम लोग क्या बोलेंगे, साइकिल बोलेंगे, and due to that there will be what, the false cycle. तो इसको किस तरीके से लिखना चाहिए था फ्रेंड्स, it should be written like that, it should be written like this. यहाँ पे प्रॉब्लम क्या आया था, यहाँ पर प्रॉब्लम ये था कि T2 से लेके T3, T2 से लेके T3 कोई आर्क है क्या, नहीं है। So this was the false thing here, okay। So how it will be written, so it should be written after generating this graph, we should write down this. So what this graph is telling us, T3 gives us T1, then it is dependent on what, T2, and this is what the right sequence where no cycle is found, okay। So false cycle will be there if you use this particular way, okay, but the right way to use is what, to we need to what, we need to combine this graph first, and based on this graph we need to generate new sequence, and this new sequence will tell you that there is no cycle, and due to that you can say there is no deadlock. So this you need to understand, my dear friends, okay। So this is what which is explained here, okay। And finally what we need to do, unnecessarily we need to roll back, and false cycle यदि identify होता है तो आप क्या करोगे, आपके पास क्या आएगा, आपके पास डेडलॉक जो भी है वो डिटेक्ट हुआ रहेगा, and once deadlock is detected, what option we have, we need to roll back all the transactions. So unnecessarily rollbacks यहाँ पर क्या होंगे, यहाँ पर हो जाएंगे। This is what the severe drawback of this mechanism, okay। So this is what the last slide that I wanted to share with you, and it is now over from my end. आपका unit number 5 जो भी है यहाँ पर complete हो रहा है। From tomorrow we'll start with what, unit number 6. Though tomorrow is Thursday, I don't have any lecture, but I may take what, the lecture of Domse sir or DR Agrawal sir, because they have completed their session, and I'll let you know in the morning. So my dear friends, I'll see you. You all have to take care that I will lecture tomorrow without fail, and we'll start unit number 6 into that particular lecture. If you have any doubt, you can please ask into chat window. I'm sharing with you the attendance link Dear friends, if you have doubt, you can ask. I have shared the link of attendance on Zoom chat window as well as YouTube chat window. If you have doubt, you can ask. You can unmute yourself, you can ask, or you can put it on chat window. Today we have 7 minutes, so we can discuss. If you have any doubt, you can ask. I think this friends, if you have doubt, you can ask. I have shared the link of attendance on Zoom chat window as well as YouTube chat window. Oh. If you have doubt, you can ask. You can unmute yourself, you can ask, or you can put it on chat window. So this is, I think, my last lecture with third year IT students, because from 6th unit onwards, our syllabus is different. So for third year IT students, Mahale sir will deal with that. And for third year computer students, I will deal with what the 6th unit. I think he has already completed the 6th unit, I guess. So dear students, IT students, I would like to hear from you the feedback of, please tell me very frank where I should make a change. दोस्तों आप इन्फॉर्म करोगे, आप मुझे बताओगे तो आई कैन मेक अ चेंजेस. IT students, it's time to give feedback. Any one or two, I'll be happy. समझ में आया है क्या आप लोगों को? जो भी चल रहा है वो समझ में आ रहा है क्या?
Yes, sir.
Yes, sir.
Yes, sir.
इंटरेस्ट जनरेट हो रहा है? अच्छा, इंटरेस्ट जनरेट नहीं हो रहा है. When you are saying nothing, it means that
Yes,
it is
sir.
no. Okay. So anyone, any IT students, I'll be happy to know from you all. IT,
Sir,
IT students. Yes, Rutuja.
there is nothing changes in your teaching method, and teaching method is really good. And first,
Thanks a lot.
and I like your PPT presentation. मीन्स यू मतलब आपने बहुत अच्छे से पीपीटी डिजाइन किया है सर, मतलब हम लोगों को रीड करने में भी कोई प्रॉब्लम नहीं होगा.
That's good. Thanks a lot. There are certain members which are involved into developing this particular PPT. Special thanks to them also, along with me. Third year IT, anyone? This is opportunity that you are getting. आप इंग्लिश में बोलो, हिंदी में बोलो, मराठी में बोलो, ईरानी में बोलो, मारवाड़ी में बोलो, गुजराती में बोलो, कोई प्रॉब्लम नहीं. Happy to listen. है क्या थर्ड ईयर IT के स्टूडेंट्स है क्या यहाँ पे अभी?
सर मैंने ही दिया फीडबैक आईटी के स्टूडेंट.
Yes, you have given. I want one more feedback. Both side. किसी को यदि कुछ सजेशन करना है आप बिल्कुल कीजिए. That will help me for what improvement. Rutuja is always giving what feedback. I'll be happy to listen from other members also. कंप्यूटर डिपार्टमेंट के स्टूडेंट को चांस दूंगा मैं 6 यूनिट कंप्लीट होगा तब. Okay, Snehal has given that your teaching method is perfect. Thanks, Snehal. But any suggestion for improvement? Don't leave the class because we have to take the photograph today. Any other third year student?
हेलो सर.
Yes, भावे बोलिए.
सर आपकी टीचिंग में ऐसा कोई पॉइंट नहीं कि जो हमको मतलब हम उससे सीखते नहीं यार, कुछ हम गलती निकाले ऐसे कुछ भी नहीं.
ओके. तो आपके एंड से जो चल रहा है वो सही है, ठीक है, कोई चेंजेस,
यस
कोई
सर।
इम्प्रूवमेंट्स की जरूरत नहीं
नो
है अभी?
सर, वो सिर्फ वो जो आप पोल लेते थे ना, वो अच्छा था सर।
पेपर के ऊपर?
ना सर, वो जूम के ऊपर जब ऑनलाइन
अच्छा अच्छा
लेक्चर्स
अच्छा
रहते
अच्छा,
थे हमारे, पोल
पोलिंग
पोल।
पोलिंग पोलिंग
हाँ
सिस्टम।
यस सर।
ओके ओके, डेफिनेटली नाउ। अभी तो आपका तो चला गया, लेकिन मैं थर्ड ईयर कंप्यूटर के स्टूडेंट्स को पक्का यूनिट नंबर 6 के लिए, हर इसके लिए मैं बना के रखूंगा। थैंक्स अलॉट। ओके, साक्षी दवांगे आल्सो सेड देयर इज रेंज प्रॉब्लम, सो अटेंडेंस नहीं लग रहा है। साक्षी, प्लीज मेंशन इट ऑन माय व्हाट्सएप so that I'll definitely put your
Yes, sir.
attendance.
Yes,
Okay?
sir.
Yeah,
Yes, sir.
Akanksha also shared her feedback. Thanks a lot, Akanksha. As you have shared it privately, so I am not taking it openly. Thanks a lot. Okay, if there is no doubt or if nobody wants to share anything, then I would like to, stop the screen sharing, and I request you all to please on your camera. I would like to see you all so that we can have photograph. कैमरा ऑन कीजिए सब लोग। Smile everyone. Come on, third year IT student. It's my last lecture for third year IT. Smile. I'll take for other screen also. Everyone please smile. Yes, thank you friends. See you all. Wish you all the best. Third year IT students, you have great future. Okay, because computer and IT branches having great future in the market. So wish you all the best. I hope you will enjoy the teaching learning process, and you definitely think about what you make your career into database management system. Thank you all. See you all. Bye.